Let's read it. Maximum number of electrons present in a f orbital is. Student, any orbital, no matter that belongs to S subshell, P subshell, D subshell, or F subshell, can accommodate maximum 2 electrons with opposite spin. That means the correct answer is option number 4. Moving to next, which is question number 67. Let's read it. Which among the following species contains highest number of unpaired electrons? Student, for this question, we have to write the electronic configuration of the given ions, and then we'll be able to calculate that which ion has the maximum number of unpaired electrons. Starting with Cr2 plus. So student, the atomic number of chromium is 24, and when two electrons are removed from chromium, one electron is removed from the S subshell and one electron is removed from the D subshell. So Cr2 plus will have 22 electrons, and the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 3d4. Two electrons have already been removed. Next we have CO2 plus. In case of CO2 plus, the number of electrons present are 25, and 2 electrons are removed from the outer 4s subshell. So the electronic configuration of CO2 plus will be 1s2, 2s2, 2p6, 3s2, 3p6, 3d7. Moving to next, Fe2 plus. Again, 2 electrons are removed from the outer 2s subshell. So the left electrons will be 24. The electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6 and 3d6. Moving to last, Mn2 positive. Students, in this case also the 2 electrons are removed from the outer 4s subshell and the left electrons will be 23. So writing the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6 and 3d5. Students, in this case there are 4 unpaired electrons. In this case there are 3 unpaired electrons. In this case there are 4 unpaired electrons, and in this case there are 5 unpaired electrons. So it is very clear that among the given ions, Mn2 plus contains the highest number of unpaired electrons. So the correct answer is option number 4. Moving to next question, which is question number 68. Let's read it. Which among the following series for atomic hydrogen falls in infrared region? Student, I'm writing here that Paschen series lies in the infrared region. Also, I'm writing for the rest of the series. Lyman series lies in the UV region, and the Balmer series lies in the visible region. Here we have to answer the series which lies in infrared region, that is Paschen series. So the correct answer is option number 1. Moving to next question, which is question number 69. Let's read it. Number of chloride ions present in 200 ml of zero point 0.4 molar calcium chloride solution is. Student, here first of all we'll be calculating number of moles of calcium chloride, and then we'll be calculating the number of chloride ions. So we know that molarity is equals to number of moles upon volume. So number of moles is equals to molarity into volume. Molarity is zero point 0.4 and the volume is 200 ml. So we'll be converting this into liter. So 200 divided by 1000, which is equals to 80 into 10 raised to the power minus 3 moles. Now students, We know that CaCl2, 1 mole CaCl2 gives 2 moles of chloride ions. So number of Cl minus ions is equals to number of moles of calcium chloride, which is 80 into 10 to the power minus 3 multiplied by 2 multiplied by Na, which is ultimately equals to 80 into 10 raised to the power minus 3 into 2 into 6.02 into 10 raised to the power 23, which is equals to 9.6 into 10 raised to the power 22. That means the correct answer is option number 3. Moving to next question. Decreasing order of stability of N2, N2 plus and N2 minus is. Student, for this question, we need to understand that stability depends upon bond order. Higher the bond order, higher, more will be the stability. So let's write the bond order of the given species. First we are given N2, the bond order is 3, and the bond order of N2 plus is equals to bond order of N2 minus, which is equals to 2.5. So it is very clear that the stability of N2 is definitely more than N2 plus and N2 minus. Now we have to compare the stability of N2 plus and N2 minus. So for these, student, we need to understand that when the bond order is same, if the last electron is in anti-bonding molecular orbital, then the species will be less stable. So in case of N2 minus, the last electron enters the anti-bonding molecular orbital. As a result, the stability of N2 minus is less than that of N2 plus. So here I'm writing order of stability which is equals to N2, N2 plus, N2 minus. That means the correct answer is option number 3. Answer is option number 3. Moving to next question.